All right, let's look at worksheet number 22, Financial Literacy 2. Here we talk about compound interest and annuity. In the last worksheet, we studied concept of interest. This is the fee you have to pay to borrow money or fee you charge to make money, to lend money. How to calculate the simple interest from a given situation. In real life, however, another type of interest is more commonly used. This type is called the compound interest. You probably heard it before, maybe not. Where the interest is added on top of the interest earned. So we'll talk in more detail, but this is more realistic case of interest where it's called compound interest. So in many investment and saving account, instead of simple interest, you earn compound interest. This is the case when any interest you earn is automatically added to the balance, or also known as principal, right? So whatever interest you earn, it'll add it to it automatically. And you earn interest on that interest year in the future, right? So you get interest on the interest that you earned. Haha. In simple interest, interest is calculated only on the original balance or the principal, right? However, in compound interest, the principal is recalculated on every compounding period. So we'll talk about it in more detail, but like every year, they'll recalculate your balance. So next year, your balance is going to be higher, so you'll get more interest on that. All right, let's look at more detail here. 4 factors of compound interest. In addition to 3 factors we already know, it's the principal P, that's how much you borrow or how much you invest originally. Interest rate, that's usually annual rate. And then time, 2 years, 5 years, always convert to years, right? We have one additional factor for calculating compound interest earned, right? So this is what's different than the simple interest. The compounding period, K, is how often interest is compounded in 1 year. Maybe I should highlight 1 year here, or 1 year. If the interest is compounded annually, that means annually just means once a year. Use K is 1 because it happens in once a year. For monthly, I'm going to say K is going to be 12 because there are 12 months a year. So if something happens monthly, that means it happens 12 times a year. So the compounding period is how often things get compounded in 1 year. So that's why K is 12 for monthly. Quarterly means 4 times a year. So K is going to be 4. If it's weekly, then it's going to be 52. If it's daily, then it's going to be 365, so on and so forth. So unlike simple interest, we have one extra factor, that is the compounding period. Okay, so how do we actually calculate the compound interest or the future value of the compound interest? So to calculate the ending balance of compound interest account, we use the following formula, right? So the future value FV is equal to P, the principal, times parentheses 1 plus R interest rate over K, the compounding period, times, it says N times, there's a typo here, it should be K, T times K. So T is time times K. So there's a typo here, it should not be N times K, it's T times K. I'll change that here, sorry about that. So side note, in the formula, T times K is the exponent. So there's the exponent right here. The exponent key in most calculator look like the up arrow or x to the y power. So it depends on the calculator you have. You have to kind of search, look for yourself, either the up arrow key, x to the y. So those are the exponent key. The formula is slightly overwhelming at first glance. There's a lot going on, right? But it'll get easier if you keep practicing a little bit more. Okay. To make the whole calculation easier, first calculate the T times K, and then will make things a little bit easier. All right, so let's kind of look at some problems here. Let's compare the difference between, let's investigate the difference between simple and compound interest and see which is better investment option. So basically, is it better to earn interest on your original principal, which is simple interest, right? Or is it better to have your interest added to your principal and earn interest on top of that as well, right? We'll see. Let's look at number 1. Calculate the future value for each investment. Okay, but the first one, invest $1,000 at 4% simple interest rate for 5 years. Well, it says simple interest rate, so this is like the old stuff. So if you remember, future value for the simple interest rate was P, 1 plus R times T. So principal is 1,000 1 plus interest rate R, which is 0.04 times time is 5 years. When you calculate that out, I'm going to get 1,200. Okay. So that means if you invest $1,000 today and wait for 5 years at 4% simple interest rate, you'll have 1,200. Pretty good. Made 200. Let's look at part B. Invest $1,000 at 4% interest rate. It says compounded annually, right? So I know this is compound interest question. So here, the part A was simple interest question. Part B is the compound interest question because it says compound interest. How nice. I'm going to highlight this compound interest annually, right? So before I get started, let's look at the formula and like try to identify which letter is what. So first of all, P is the principal, so that's how much I'm investing. So that's P is 1,000. P. 4% is interest rate, so that's R. It says compound annually, so that means my K is going to be 1, because it means once a year. So K is how many times does it get compounded per year? So just one time. And then T is 5 years. Okay. So now I can zoom in. I can use the formula here. FV is, so for the compound interest, P 1 plus R over K to the T times K. Again, as I said before, I'm going to calculate T times K first. So side calculation, T times K is just 5 times 1, which is 5. Okay, so that will be 1,000 plus, parentheses 1 plus 0.04 over K was 1 to the 5th power. Here I already calculated TK. 5 times 1, it was 5, so I'll just put 5 there. Alright, so when you calculate this out, I get $1,216.65. Okay. So part A and part B are very similar. Part A is simple. Part B is compound annually, both for 5 years at 4%. As you notice, the answer is somewhat different. For compound, I just made little bit extra money, right? So I noticed that this one gives you slightly more money. Okay. Let's look at part C. Invest $1,000, so same amount, 4%, same interest rate. It says compound monthly, so let me highlight that also. So that means, in my head, that means K is going to be 12, because monthly, so if something happens monthly, that means it happens 12 times a year. T is still 5, so part C is basically the same as part B. Instead of compounding annually, it says compound monthly, so RP. So future value is 1,000, that's P, 1 plus 0.04 over 12, because we're dividing by K, which is 12 in this case. And then again, we should have calculated our T times K first, which is 12 times 5, which is 60. Okay, so I'll just plug in 60 here. So once I calculate this out, I get 0.996, so I'm going to round off to 1, right? So again, I just made a little bit more money than before. So the simple interest is, I'm going to end it up at 1,200. With compound annually is 1,216, whereas compound monthly, more frequent, 1,221, just extra $5. Okay. So let's see if I can answer the following line here. So when the interest rate is the same, the compound interest give you more interest than the simple one, right? And if I compare compound to compound, for compound interest, the one with the more frequent compounding, gives you more interest than the one that's less frequent, right? So if you compound monthly, that's better than annually. All right. All right, now I'm going to have you try number 2, part ABC. Again, as you notice, some are compound interest and some are simple interest. Just a hint. And once you're done with number 2, let's meet back at finding principal to achieve given future value. All right. Okay, so once you're done with number 2, let's look at the next part here. Suppose you want to have a certain amount saved up to buy a computer or a car or anything else in the future, right? If you don't have achieved the goal by using compound interest, you can still use the compound interest form and then solve for P, which is the principal. So I want to have $5,000 in 2 years. So how much do I have to invest today to get that? Hopefully it's less than that, because then I'll earn money on that, right? So I'm going to still use the compound interest formula, plug in all the known variables, and then solve for P, which is principal, to find the answer. Okay, let's look at number 3. Nicole wants to have $30,000 in 10 years, okay? She wants to find the investment account that earns 8% interest compounded monthly, okay? So how much should she invest to have $30,000 in 10 years? Maybe she wants down payment for a home, or she wants to buy a fancy car, whatever. So question is, how much do I have to put in today to get 30,000? Without even calculating anything, I know it has to be less than 30,000, because the goal is to put less money so that I can earn interest. So in the future, I have more money, right? So what's the point of investing $30,000 today to get just $30,000 in 10 years, right? So my guess is like maybe 25, 27, I don't know, it depends, right? So here, I'm gonna label here with this one is not principal anymore. Now this is a future value, because this is what I want in the future, 10 years, right? So I'm gonna label that as a future value. T is 10. This is still interest rate, so R, right? So let's see if I can write out everything I know already so far. So future value is P, 1 plus R over K, T times K. Here it says compound monthly, so K is going to be 12. So as I said before, let's calculate T times K first. So T is 10 years, K is 12, so that's 120. So future value is 30,000. P, I don't know what it is, so I'll just leave it as P. That's what I'm trying to solve for. 1 plus R is interest rate was 8%. And then K was monthly, that's 12. And the next one is 120. Okay, so again, this looks slightly overwhelming. This is one number. This is kind of crazy, but once I calculate this out, it'll just give you one number. So let me calculate this out. Hopefully it'll get a little easier. So this becomes 30,000 is equal to P times, the complicated part is just 2.219640235. Generally speaking, I don't want to like round off in the middle of the calculation. My final answer I usually round off, but in the process of calculation, I'm going to try to keep it as not rounded as possible, just to get the most accurate answer. So okay, so I have the formula here, equation here. I want to solve for P. P is multiplied by this thing, right? So here, can I just divide both sides by this 2.2 number? Then I can have P by itself. So that's exactly what I'm going to do. So divide by 2.2196 dot dot dot, divide by 2.2196 dot dot dot. Once I do that, then these two will cancel out, and then you get P by itself. So when you calculate it all out, I got P is equal to 13515.70. Okay, so 13,000. Oh wow, nice. So that means if you invest $13,515.70, wait 10 years at 8% interest compound monthly, it will become 30,000, right? All right. Let's look at the next question. What if the interest rate was 8% simple interest? Well, then I just use the simple interest formula. So future value for simple interest is this. And then basically, okay, 30,000, still future value. Principal, I don't know, 1 plus 0.08 times 10. Again, I'll calculate this part by itself already. If I calculate it out, they're going to get 1.8. So 30,000 is P times 1.8. So I'll do the same thing. I'll divide by 1.8 both sides. So here P is equal to, so 30,000 divided by 1.8 will give you 1666.67, right? So with simple interest, you have to invest 16,000 something to get 30,000 in the future, whereas for compound interest, you only have to invest 13,000 something to get 30,000 in a year. So that's a good comparison too. I'm gonna have you try number 4 and number 5. Number 4, 5, and 6. If you answer those, and then after that, let's meet with the annuity section. All right, when you're done with the previous questions, let's look at the annuity. For many people, it's hard to come up with a lump sum. It just means chunk of money, big chunk of money, to save for the future, retirement, or any other occasions, buying a car, down payment for your home, whatnot. More common way to save is called annuity, where you make a series of fixed amount of money instead of like a lump sum. Here, the interest earned is also compounded. So basically, you make a same amount of deposit or payment, or investment on each compounding period. So for example, if you decided to invest or deposit or save $50 a month for the next 20 years, then it will be an annuity, example of annuity, right? So here we have 4 factors of annuity. To calculate the future value of annuity, basically we need to use more complicated version of the compound interest. As I said, we use compound interest, but instead of one-time lump sum deposit, here we're making a series of deposit, like every month. So instead of investing once, we're making investment every month, right? So things get a little more complicated. Similar to the factor of the compound interest formula, the annuity formula also needs 4 factors. So interest rate, compounding period, time, and then payment, which is how much you deposit, invest. And for annuity, the compounding period is basically how often you deposit. So if you're depositing every month, then the compounding period is monthly. If you're depositing every week, then compounding period is weekly, and so on and so forth. So how do I actually calculate the future value of annuity? So the formula is pretty complicated, so we're not going to actually do it by hand. We're going to use Google Sheet function to calculate the future value of annuity. So luckily we have Google Sheet, so we'll use that. It calculates for me. So the function is equals FV for future value. The first number you want to plug in is periodic interest rate. And the second number you want to input is total number of deposits. So it means how many times you deposit things. And then the third one is payment amount. So which translates to, in terms of symbols, R over equals FV R over K, and then K times T, and then D. D was the payment amount. The periodic rate, interest rate, is the interest rate. Because interest rate is given annually, you have to kind of convert that to like each period. So interest rate divided by the compounding period. So for example, if the interest rate is 4%, is compounded monthly, basically I'm going to just divide 4% by 12. The total number of deposit is time times the compounding period. For example, if you're investing each month for 20 years, then basically the total number of deposit is 20 times, what did I say? 4, it's 12, which is 240. That means you're basically investing 240 times, right? All right, let's look at the next question here. For each question, identify the variable, and each number is representing, and find the answer, okay? John wants to set a 401k. This is just the annuity name it's like very typical name of the annuity. And invest $75 a month at the end of each month, okay? Into account that earns annual interest rate of 6% compounded monthly. Okay, there's a lot of information here. A says find the value of a 401k after 10 years. Okay, so let's see. He's investing $75 a month, so that's my D, that's the amount depositing. Interest rate was 6%. The compounding period is monthly. It says monthly right here, so K is going to be 12. And then for how long? 10 years. Okay, T is going to be 10. Okay. So again, I'm going to use Google Sheet. I'm going to use equal future value. I'm going to do 0.06 over 12. So that's periodic rate. So I'm going to take the interest rate divided by K. So R divided by K. And the next number I want to plug in is total number of deposits. So I'm doing monthly for 10 years. So it's 12 times 10, which is 120. And then the last one I'm going to plug in is how much you're investing, which is the payment amount, which is 75. Right, so when you calculate it out, you're gonna see negative 12,290.95, right? Because they think you're making a payment, so it's negative because it's like accounting was. So either you can just ignore the negative because you're not gonna have negative amount, and just say, well, $12,290.95. Or when you type in the future value function, if that bothers you, you can put negative in front of it. So either you can type it in and just ignore the negative, or you can put negative in front of FV, then negative times negative will be positive. So your answer is going to come out to be positive. The second part of the question was how much interest will he have earned? So this is how much he's going to have at the end. So again, to find the interest, you have to kind of look at how much did you invest versus how much you ended up with, right? So let's look at how much he invested. Total amount invested. So he's putting $75 a month for 10 years. Each month is going to be 12. I mean, each year is going to invest 12 times, right? So total number of deposit is 12 times 10, So how do I calculate how much he invested? 75 times 120 basically, because he deposited 75 120 times. When you calculate this out, I get 9,000. So basically he put in 9,000. He ended up at 12,290. Oh, that's a pretty good deal. So total interest earned will be then 12,290.95 minus 9,000. So it'll be $3,290.95. So that's how much he made. Okay, cool. I'm gonna have you now try part B, and I think now you can basically finish the rest of it here, right? I'm gonna post the separate video for more detailed explanation of the future value function key, so you can do that, but I think you can finish the rest of the worksheet.